In this video, we're going to start talking about derivatives and the power rule. Previously, you may have learned how to derive from one function another function that gives you the instantaneous rate of change of at a certain point. This is called the derivative. And when you first learned this, you probably used a really long, drawn-out process which involved using limits, and which really takes a lot of time and takes a lot of paper. Well, luckily, there's actually an easier way to get the instantaneous rate of change at a specific point, or get the derivative. And in the case of a polynomial, we use what's called the power rule, and it works very, very easily. It works like this. So let's say you're given a function here. We'll say it's called f at x, okay? And that function equals x to the power of r. The equation for the instantaneous rate of change, also known as the derivative, will be given by the function f prime at x. It's written as f prime at x. And it will be equal to r times x to the power of r minus 1. So as an example here, let's say that you're given a function f at x equals x cubed. Okay, so what would f prime at x be? In this case, f prime at x, for this example, we would use our power rule. So in this case, r here is 3. So we would write 3 here times x to the power of 3 minus 1. 3 minus 1, which is equal to 3x squared. Okay, and it's that simple. So this function right here will give you the instantaneous rate of change at any point corresponding to this function here. So for example, let's do a quick practical example here. Let's say that you were given a function that models or describes the position of an object with respect to time. So let's say I'll write this down first. Okay, so let's say you had a ball and you threw it off a building and it starts to decelerate downwards. You want to know exactly not only where it is at a certain point in time, but you also want to know how fast it's going. Okay, and we'll say this is in meters. Okay, so let's say, actually, let me just quickly rewrite this here to make it a little bit more consistent. So we'll call it d at t instead of d at x. Okay, so the position of the ball at some point in time. All right, and you're asked to find how fast the ball is going at 1 second. Okay, so 1 second after you've thrown the ball. Okay, so v at 1 second. Okay, how fast is the ball going after 1 second? Well, it turns out that v at t is equal to the derivative of d with respect to t, so d prime at t. So in order to get the equation for how fast the ball is going, we just take the derivative of the position function here. So let's go ahead and do that. Okay, so that'll be d prime at t is equal to, so we'll take the 2, multiply that by the 4, or the negative 4, which would be negative 8, times t to the power of 2 minus 1, which will just be 1, and we don't need to write the exponent there. So therefore, if you want to find out what v at 1 is, okay, or d prime at 1, okay, which is the same thing as v at 1 second, we'll say, okay, and let's say that this function here is in meters. Okay, so v at 1 second, we would just sub 1 in to this function here. So it'll be -8 times 1 second, which will give us -8 meters per second. And that's how simple it is. So let's do another example here. Let's say you're given a function f at x is equal to x to the -3. What is f prime at x? Okay, f prime at x. Also, another way of writing f prime at x, okay, is df by dx. Okay, so the derivative of f with respect to x, f prime at x. Okay, so what would be the derivative? Again, same thing. We just take that exponent and make it a coefficient, and then we would subtract 1 from -3, which is -4. And there you have it. Okay. If we were to do another example, let's say you are given this example, for instance. Let's say you get g at x is equal to 3x cubed plus x squared minus 4. Okay. What would g prime at x be? Okay, g prime at x. Okay, you can also write it as dg by dx. Okay, what does that give us? It'll be the exact same thing. The only difference is here we just have multiple terms here. So we'll do the power rule for this term, then the power rule for this term, and then the power rule for this term. So over here we'll write, so 3 times 3 is 9, 9x, and then 3 minus 1 is 2, plus, okay, 2 times 1, okay, is 2x, 2 minus 1 is 1, so we'll just leave that there. And then for the 4, since it does not have an x there, that just cancels out to 0. So the answer would be 9x squared plus 2x. Right? Pretty straightforward there. Okay. Let's do one more example. So let's say we're given this function here, h at x is equal to 2x cubed minus the square root of x plus 5x. How would we evaluate h prime at x? Well, the first thing we want to point out is that this, okay, root x can also be written as 1 over x, or excuse me, x to the power of 1 over 2. So 2x cubed minus x to the power of 1 over 2 plus 5x. So to evaluate that derivative, h prime at x, okay, also written sometimes as dh by dx, we will write it like so. So again, power rule, 3 times 2 is 6x, and then 3 minus 1 is 2, minus, okay, 1 over 2 times x, so that'll be 1 over 2x, and then 1 over 2 minus 1 is negative 1 over 2, plus, okay, 5x. So here, there's an imaginary 1 here, so it'll be 1 times 5, and it'll just be 5, and then we're going to decrease the exponent here, so 1 minus 1 is 0, and anything to the power of 0 is just 1. So we would write it like so. And then we can further simplify this equation here. So we write 6x squared minus 1 over 2 times, another way of writing this term right here is 1 over x to the power of 1 over 2 plus 5. And then simplifying it even further, we can write it as such. So 6x squared minus 1 over 2 times root x plus 5. Alrighty. And so there you have it. That's the power rule. It's relatively straightforward. It's not too difficult, and it's great because it makes it very easy to evaluate polynomials, especially some that are really big polynomials or long polynomials or polynomials with big powers like 3 or negative polynomials. It's kind of hard to do that doing limits. So if you use derivatives, you can do it in seconds. So that's it for the power rule. In the next video, we're going to talk about, or in the next set of videos, we're going to talk about derivatives for trigonometric functions, which are pretty interesting, starting with the derivative of a sine function. Thanks for watching, and we'll see you in the next one.